Okay, so we spent an entire chapter talking about operations with monomials, right? And what was a monomial?
One.
Mono means one, okay? So we have a number, a variable, or a product of a number and a variable. Okay, so we worked with taking monomials and multiplying them, or dividing them, or taking them to a power, or whatever, okay? That was chapter 6. Okay. Now, let's talk about the degree of a monomial. Okay, so the degree is going to refer to, okay, if it's a monomial, the sum of the powers. Okay. So if I have like 10x squared, it has a degree of 2 because that's the exponent for x. Okay. What about 5x? What would that have a degree of?
1.
It would have a degree of 1 because that's the exponent for x. Okay. But what about this one? 24x squared y cubed.
So it's going to have an x. It's going to have the x is going to have a degree of 2, and the y is going to have a degree of 3.
Okay, so altogether, we're going to have a degree of 5. See how Joey got to 5? This 2 and this 3 together, it's a 5. Okay. Your face is telling me that you don't like that. Oh, it's so bright.
Well, something's
Then that means that it's just a number without a variable. Like this right here, this would have a degree of 0. Okay. Okay, so we've already talked about monomials. Now we're going to talk about polynomials. Okay? Polynomial is a word that you are going to hear a lot, not only in this class, but in Algebra 2, pre-calculus, all the things. Okay? So a polynomial is the sum of monomials. So you have 2, 3, 4, 5 monomials that are not like terms. Otherwise, we'd add them together. Okay. We will see binomials, trinomials, and polynomials with a varying amount of terms, okay? But when you see the word binomial, what number is associated with bi? 2, like a bicycle has 2 wheels, okay? A binomial is the sum of 2 monomials. So there's 2 terms. Okay. Like maybe it's 5x cubed plus 3x squared. That's a binomial because there's 2 terms. Okay. What number do we associate try with? 3. A tricycle has 3 wheels. So a trinomial is the sum of 3 monomials. And we're really going to be friends with trinomials. Okay. Now, if I ask you for the degree of a polynomial, okay? A polynomial means there's like, dang, that just popped all the way. I think it's in Camden's lap there. Okay? A polynomial has monomials added together, right? Or subtracted. Okay? So when I ask you for the degree of a polynomial, I want you to go to the one term that has the highest degree. Okay? So like if I was looking at this trinomial right here, what is the degree of this polynomial?
X.
Okay, our degree would be 2 because x squared, that's our highest power. Okay. Now, there are times where I have not been very picky about the order in which you write your answer. Okay. We have come to a time where we need to be picky. Okay. When you write a polynomial, I need you to write it in order from highest to lowest degree. Okay. If you are combining like terms and then writing your answer, I need the highest degree first, then the next degree, and so on. Okay. And then the leading coefficient, as long as we have it in what we call our standard form, okay, our leading coefficient is the coefficient that's with the highest degree term, okay? So as long as we have it in standard form where our highest degree monomial is first, what is that coefficient? That's our leading coefficient, okay? Might not be as big a deal today, but here after spring break, the leading coefficient will be really important when we get into what I call factoring, okay? So, we have our vocabulary, okay? I want you to look at the bottom of the next page. If I look at number 5, what's the degree?
3.
The degree is 3. Okay, because we have 1, 2, 3 total for our exponents. Could you write down what you think the degree is for 6, 7, and 8? Vivi, what do you think about the degree for number 6?
I think it's the degree is 6.
You think the degree is 6. We have 1, 2, 3, 4, 5, 6. Okay. Willow, what about for number 7? 4. We have a total of 4 in our exponents. What about number 8? What would not be? Be 0. Do you see a variable?
No.
Nope. So our degree is 0. Okay. Okay. Now, turn the page. Okay. So I told you that when we write a polynomial, we need it to be in descending order with our exponents. So who has the biggest exponent here? Okay, so the 3x squared. Then what are we going to write? Plus x, and then our plus 5. Okay. What's the degree of this? It would just be 2. We go to the one term and we count its degree. Okay? What do we call 3?
The coefficient.
The 3 is the leading coefficient. Okay? Now, what kind of polynomial is it?
It's a trial.
It is a trinomial because there are 3 terms. So it's a trinomial of degree 2. Okay. So what I'd like you to do, I'd like you and your elbow partner to rewrite number 11 and number 12 in standard form. And then identify what's the degree and whether it's a binomial or trinomial. Ready, set, go.
I have the smartest elbow partner.
What'd you say?
I have the smartest elbow partner.
Yeah, you do. The best conversationalist, too.
Oh.
Okay, as I'm looking over the shoulder of a random student, I see that in number 11, this random student has 6x to the 8th plus 3x to the 5th. Do you agree with that being in standard form?
Yes.
Okay, we have a degree of 8, and there's only 2 terms, so it's a binomial.
Can I be the student who showed you the color?
Oh, so the random student for number 12, I see f to the 4th plus f squared minus 2f, which is a 4th degree trinomial. Yeah?
Yes.
Okay. Okay, so from here, over the course of today and tomorrow, you need to be able to add, subtract, and multiply polynomials. Okay, so we're going to start with the easy, add and subtract. Okay, so if you look at number 13, here we have 2 polynomials that we need to add together. Okay, are those parentheses affecting anything? No, it's just saying, hey, this is polynomial number 1, and this is polynomial number 2, and we need to add them together. Okay? Essentially, what am I asking you to do? Combine like terms. So I have negative 4x plus 9 plus 6x minus 14. This is a combined like terms problem, okay? The parentheses are just separating out the two different polynomials. So we have, I think it's 2x when we combine our x's. Okay, 2x minus 5. Done. That's it. Okay, yeah.
Do we have to put them in order?
So your final answer does need to be in standard form order, okay? I will be picky about that now, since we're working specifically with polynomials, okay? So, you know what? Let's go to number 15. Okay? We are adding two trinomials together, both of degree 2. Okay? I'm just going to ignore these parentheses. Okay? What happens when I combine my x squareds together? Ooh, nice. What about our x's? And then our constants. So I write 9x plus 1. Right, so your answer should be written in order. Okay? Correct.
So would the variable always be bigger or not all the time?
So, like if you have a squared,
Yeah.
and then,
No, I'm saying like with the coefficient and the variable swap.
I don't know if I understand what your question is, Joey. Like the 9 and the x?
No, I'm saying like with these two swapped.
They would not. I need it 9x and then the plus 1. Okay? The term without the variable always has to come last. Now, I want you to look at number 17. 17, what's our operation? Subtraction. Here the parentheses does matter. Okay? For the first one, not so much. We just have g minus 4. But we are subtracting all of the second one. So can everybody watch what I do up here? We are subtracting 3g, and then we are subtracting a negative 6. Okay? Subtracting a negative 6 just means we're adding 6. So what I'm going to do is I'm going to take that minus, and I'm going to take it through my second polynomial and adjust it. So now I can combine like terms. Now I can combine my g's to be negative 2g, and I can combine my constants to be plus 2. Bless you. Okay. Let's look at number 19. Okay. Our first polynomial is negative x squared minus 5, but then we're subtracting a trinomial. So we're subtracting a negative 3x squared. So I'm going to make it a plus x squared. We're subtracting a negative x, and we're subtracting a negative 8. Okay, so I'm going to rewrite that second polynomial with the subtraction through it. Now I can combine like terms. I'm going to start with my highest degree. I'm going to start with my x squareds. Then I'm going to go to my next highest degree.
So it would just be x by itself.
Okay, and then